Hi, I'm Agostino Bruzzone, simulation team, here with double hat of Sim for Future, University of Genoa, in cooperation with several authors, Professor Sasho Maken, Dr. Marina Massei, as well Paolo Di Bella, Ian Mazal. I'm going to present you something that is about the strategic engineering. So let me share the screen, one moment, very quickly, and I will start immediately. Okay, so I feel you see now my screen. So the idea is about dynamic problem solving for assessment of strategic engineering capability. This is a project that is an example of how we can do issue in order to reduce, make an assessment of the skill in strategic engineering, and this is applied to a case study we developed. It's a fictional case study, but pretty realistic. Let me say that illegal weapon traffic at sea is a major issue. It's quite complicated. It requires to coordinate activity, to fuse data, is even to fuse information by different sources to identify where to go, where to act. And normally you have limited resources to carry out this activity. So it's very important to identify how to do. With strategic engineering, obviously we can have an advantage. We can collect information about the flows of goods, from where they come, with insurance, port of start, port of destination. I talk illegal armed traffic on the sea, and some kind of blockage, some kind of maritime interdiction to protect the areas from traffic of weapons that are illegal. How it works, strategic engineering. STRATEGOS is an initiative started in Genoa and is very consolidated about developing strategic engineering as a Master of Science PhD, but even as a concept. You start to get the data, you analyze, filter the data, use this data for model to look forward what will happen in the future, and then based on what will happen in the field collecting data, you identify how to correct the models. In naval framework, abilities is very interesting, but in traditional, let me say, joint naval operation, but even on asymmetric warfare in terms of logistics, port activity, maritime, as well as in the case that I just mentioned that is dealing with weapon traffic. Strategos, I was saying, is just dealing with that. Is an implementation of strategic engineering that combine model simulation, data analytics, artificial intelligence in closed loop with the big data arriving from the field that require a lot of effort in order to be filtered, and can be in some way create people that create solution to address this aspect, but we need to prepare people to master this technology. So this is the reason why we like to have some assessment of the open of mind of the potential of people in using strategic engineering. There's a huge interest from industry, as you can see, big industry as Leonardo, as Thales, as MBDA, etc., consulting firm as Accenture, and even NATO centers and some mid-sized enterprise. The case I propose you is this one, where you have weapon traffic on an area. It's functional applied to the area of grenadines, but it could be anywhere. And you have to investigate how to deal with this problem that require to combine different aspects. First of all, what data do you process? You process very different data. So you have ships that could be a yacht, a boat, a rigid hull inflatable boat. You have agent on the ground. You collect information by AIS, so by satellite position, ESM, image. You have a patrolling corvette on the area that uses own sensor. You have agents on the field. You have infiltrated people. You have some kind of ESM and decking system, and let me say web watching, and you have even information from the field about what it happened. Around 1/8 of a million report per day if you sample just by 10 millihertz. So it's very low rate, you have huge quantity of data. These data are something like that. This is an example. This report is full of information. For instance, say yes, that at this time, NAIS, that means the satellite of a ship, transmitted its position to avoid collision. We know its coordinate, we know its speed and direction, the flag, and some other one. These information are not always complete and homogeneous, and you needed to fuse in order to identify a track, because these are plot on the map, but along the time you can find this information. And you can combine with SIGINT and the lint information to cross communication to identify what is the subject, because if you want to inspect If you want to block some suspect, you need to identify where it is. Even decimating, and we decided to decimate for using for an assessment made by a young engineer. So we provide this as a case with a framework where it can play. It's a lot of data. We talk about 1 million data generated in 4 days at just this low level of frequency, while in the reality frequency is by seconds. There are not just position and radar tracking, but there are SIGINT and UMINT. UMINT is a report from somebody on the field. The say asks, for instance, in this case, the suspect carried at this position is a small ship with the flag from UK that is a cargo, sorry, that is a cargo that move over there, and I have reported that is not synchronous. So it means something that happened in the past or something that they expect to happen in the future. These asynchronous characteristics make it even harder to fuse the data together because they're related to different source, different platform, different sensor, different times, and even different relevant or reliability, because local Coast Guard is different what you see by yourself, and so on. OSINT is very important because a lot of information came from open source intelligence that could provide you information that is not just satellite, but even web communication. Often over there is hidden some material, or you can identify something happened even indirectly, because some smuggler is going there and other people don't go there. This is an evidence of how you fuse data. UMINT, SIBINT, SIGINT, and even the sensor of the vessel are part of the game. In this game is supposed, what is your goal? Your goal is to demonstrate you have a capability to define models, to define data fusion algorithm, to define artificial intelligence criteria or solution, to filter data, and to support the planning for inspection by the corvette that you have. You have many symptoms and suspects around that could be very different kind of traffic, very different alerts, very different source that can inform you about risk. And you have to define an architecture that identifies this risk. But even if you go at low level, so you want to fuse geospatial asynchronous data, this is interesting. For instance, to identify if there is suspect matching, if there is some combination of satellite image with AIS, with radar tracking. And this one is a basic data, no, it's not basic data fusion, quite sophisticated data fusion, but it's a way to measure. We create a simulator, or not just a simulator, but a real strategic engineer approach to combine simulation, data analytics, etc. It's called C3EA, Machine Smuggling by Strategic Engineer Approach. This is the general architecture, as you can see. Is 3 main modules: simulation analyzer, simulation model, smart planner. The user can play with the key parameter and can show if understood the concept. The situation analyzer take the data based on the criteria that they fuse together. Simulation, so it say you what happened in the past, so a posteriori. A priori analysis made by simulation model. And smart planner try to identify the best strategy to mix together and to identify, for instance, the patrolling of the corvette, just patrol, or just go to inspect some boat, or to stay in an area to prevent something happen over there. This is a graphic interface of C3EA, where you have all the track. As I told you, we talk about hundreds and hundreds of boats, yachts, communication, and a million of data, literally, that are collected. The scenario I mentioned, it's happened in this area between Grenada and St. Vincent, is obviously fictional. You have traffic of ship even out of your interdiction area. And your corvette could be assigned just some kind of order, and the smart planner should provide this order. And you have to define the principle to feed the smart planner, as well as the principle to fuse the data, as well as characteristics. This scenario, where the regular cargo ship have different speed, but around 15 knots. The inspection time take 1 hour. What is the weather in the area normally, but even bad and good condition that affect all the operation, if there is the moon or if it's not the moon, based on the night operation. And you have different kind of aspect. The area that we inspect is around 100 nautical mile by 100 nautical mile with a single corvette, because even should be sustainable. Probably the same approach could be designed to be used to define what is the fleet, what kind of sensor you want to use, if you want to use a corvette, if you want to use UAV, if you want to use just agents on the field, etc. There are many stochastic factors that influence weather, etc. And there is even limited number of degree of freedom for decision making. In this way, in this case, the degree of freedom are just about the planning of operation from the convert. So who inspect, where to go, where to patrol, how to patrol, is a spira, is a segment, is addressing some boarding, etc. So this provides a quick overview, but the concept is interesting, and it could be a very good way in order to identify the capability, because by playing this game, we have the possibility to identify if the user is have clear in mind the concept of strategic engineering can apply. If you have any question, I will be glad to answer by email. Thank you very much and have a nice day.